Alrighty, so we've established there are lots of different databases out there, tons and tons. This is a very small subset here. And within this very crowded world of databases, there's generally two types, two divisions between the databases. There is a group called relational databases, and then a group generally referred to as NoSQL or non-SQL, NoSQL databases. So this is an important distinction. We're going to be learning Postgres, which is a relational database. A relational database is a database that stores information, it stores the data in tables, kind of like a spreadsheet, where we have rows and columns, kind of like this here. And within those rows and columns, we store a bunch of information. And the term relational comes from the fact that usually these tables are connected to each other in some way. They reference other tables. They store relationships between pieces of data. For example, if we were making a movies application where users could rate movies, kind of like IMDb, so you need to sign up. So we'll store users' information in a users table. We would store name and email maybe, user, profile picture, a bio, something like that. Then we have our movies table. And then we might have a ratings table. And that ratings table really combines information about movies and about users. Who's doing the rating? What is the rating, a 10 out of 10, a 5 out of 10, and what movie are they rating? So that's where the term relational comes from. A relational database or relational data store is a database that uses tables or tabular data structures to store the information. Rows and columns kind of looks like a spreadsheet if you were to visualize it. But we don't actually look at it. It isn't a spreadsheet that we look at. There are tools that you can use that will view or help you view your data and make it look like a spreadsheet, but it's actually stored in a crazy, ugly, impossible to understand way, which is what makes it so efficient. But it is stored in these structures that are table-like. So this other group of databases, NoSQL or non-SQL databases, kind of forego this entire concept of tables and of storing data in these spreadsheet-like rows and column systems. There's actually multiple types of NoSQL databases. There's a group called key value data stores. There's another group called graph databases. There's even another one called column databases. All that you need to know, for now at least, because we're not going to learn a NoSQL database at this point, all you should know about them is that it's a different category of databases. They do store information. Generally, they give you more flexibility. So you don't have to store your data in tables. You don't have to follow particular formats. You don't have to define a pattern for your data. They give you more flexibility, and that can have a lot of advantages, but it can sometimes come at the cost of efficiency or scalability. All of these databases have various strengths and weaknesses, and for the apps we'll be building, unless you start getting to millions of users, any database, SQL or NoSQL, relational or NoSQL, will work just fine. So that's pretty much all I'll say about the topic for now. Just know that certain databases, like MongoDB as an example, it is a NoSQL database. It is not going to follow a lot of what we learn about Postgres, whereas SQLite and MySQL are relational databases, and they're like 98, 99% similar to Postgres. The syntax we'll be learning for Postgres will apply to these two, for the most part. Mongo is its own thing. It is a NoSQL database. It is not relational, and that's all you need to know for now. Okay, so other key terms that will come up. This is a fun one. RDBMS, Relational Database Management System. So we have our database itself, which is the actual information that's being stored, and then we have this RDBMS, a Relational Database Management System, which allows us to interact with our database. It is the software that we run that communicates our queries. So when I say, I would like the last 10 users to sign up, please give me them. Or here is a new user I'd like you to insert. Here's its name and email and password or whatever. Probably not going to store the password directly, hopefully. But whatever the information is, I am talking to the database. I'm actually storing information or querying, retrieving, updating, deleting data through this interface, the RDBMS, the Relational Database Management System. So Postgres is an example of one of those things. I don't want to say it again, RDBMS. Another term you might hear is schema. So a schema is our representation of our database. It is like the game plan for how we're going to structure our information. So in a relational database, our data conforms to a pattern. This is one of the potential downsides, one of the things that people don't like about relational databases, sometimes at least, is that you have to write out an expectation for what your data will look like. Like we have here. For movies, I've laid out a simple schema that says a movie has an ID, a title, a year, and a genre. But what happens if I have another movie that, I don't know, somehow has 2 different years it was released in, maybe 2 different versions, or it has multiple titles, that's pretty common, or it has multiple genres. I don't know why I didn't start with that. Parasite, for example, is like a hybrid comedy drama, or Amelie is a comedy / a bit of a drama, romantic film. I can't really convey that here. If this was a real SQL database, if this was Postgres, I'm allowing for exactly one genre, or 1 year, or 1 title. Now that doesn't mean we don't have options. If we wanted to have multiple genres or multiple titles, we just have to structure our database differently. We have to write a different schema. But with no SQL data stores, we have more flexibility. We don't have to follow a pattern. But that does come with some overhead, and there are some downsides to that. So it's not like we're losing out by using a relational database. These are still very much the standard way of storing data. Relational databases have been around a long time. Some of you have probably come into contact with relational databases, especially this term, SQL, SQL. It stands for Structured Query Language. So even if you're not a developer or you've never worked in a coding, engineering context, a lot of the people I've taught and that I've worked with have some experience. They've at least come up against some sort of SQL, whether they were in marketing or in payroll or in consulting or whatever it is. It's pretty common that your company, if you work at a company or you have in the past, had some sort of database, and in all likelihood, it was probably a SQL-based database, a relational database. So SQL is the language that we use, it's human readable, that we use to query our database. It is how we ask for the top rated movies or the most recent movie to be added in, or it's how we specify I'd like to delete all movies that were released in 2019 for some reason, or I want to insert a new movie called Parasite 2. I want to edit Parasite 2's genre to be drama. These are all different sorts of queries. Those aren't actual SQL, of course, but those operations are things that we do with SQL. SQL is the language we use to talk to and interact with our database. And the good news, if we use a relational database at least, like Postgres, MySQL, SQLite, these all are relational databases and they all use and understand SQL. Now there are some slight differences, but 99% of the syntax will be exactly the same. So if you do learn Postgres, which we are, you can easily jump to MySQL if needed. There is a SQL standard, it's its own standalone thing, and different relational databases implement that standard. Okay, the next important term is table, also known as a relation. So table, or a table, is basically what we have over here. Visually, I'm representing a table here as a spreadsheet. It's a collection of structured data. It's organized, right, into different columns and different rows. Those are our next 2 terms. A column is a single table attribute like ID. Everything in this movies table has an ID. Everything has a title, a genre, a year. Those are the columns. So that's the genre column, here's the year column, here's the title column. And then we have rows. So rows represent a single record into one of these tables. So it has values for each column unless we make these columns optional. But for example, the thing right here, this last row, that is a row. It has an ID, a title, a year, and a genre. Here's another one, Amadeus, great film. I know I've already said that a couple times in this course, great film. Definitely recommend watching it. It has an ID, a title, a year, and a genre. So we've got the entire table, then we have columns like genre or year, and then we have rows like this row here, row 3 on my spreadsheet, row 1 in the table itself. All right, so now that we have that terminology out of the way, we can dive deeper into databases and specifically into SQL. That's really where we'll spend the bulk of our time with Postgres, is learning the ins and outs of SQL. We need to understand SQL in order to make queries so that we can talk to our database. We can add things in, delete things, update things, and also select things. A lot of what we do in SQL is retrieving data. And there's a lot of different ways we can do it. It can get quite interesting and complex. It can also be pretty fun. So we've got a lot to talk about. Now we've got some of this terminology out of the way. Really, the most important ones here are going to be schema, table, column, and row, RDBMS. It comes up, but it's not like some people are using this in a daily conversation on the job. It's a pretty weird term and annoying to say out loud, as I'm discovering here. Okay, so next we're going to do a little bit more of a demo with some tables, and then we'll move on to installing Postgres.